So 6.5 is all about graphing polynomials. So that is our learning target today. Can we graph polynomial functions? You will have your calculator on the test. So today is really all about making sure we know how to use the calculator. The thing about polynomials is their shape, they're all over the place, right? The shapes that we see with polynomials can be very funky. With a line, we know exactly what it's going to look like. With a quadratic, we knew exactly what it was going to look like. But once you start going to high-level polynomials, you just don't know, right? We could have a shape that looks like this. Okay? Now, in order to be able to graph these, we have to grab the most important points. Things like maximum, minimum, zeros. On this random polynomial that I just drew, how many minimums do I have? Two, right? These two represent minimums. So that is really what you're going to start looking for, is two minimums. So the first thing you do is you're going to look at the graph and say, okay, how many points do I need to really grab from the calculator? How many maximums do we have? 3. Just the one. We only have this one maximum. So a maximum is when you change from an increasing slope to a decreasing slope. So we're going to look for these maximum points as well. And there might be 1, there might be 0, right? There could be an instance where you don't necessarily see all of these. And then lastly, we need our x-intercepts, our zeros, our roots, our solutions, all those things we call them wherever they cross the x-axis. So today is really just practicing with the calculator. Remember that old left bound, right bound guess? That is what we are going to do today. And that's why I say our notes are really not that lengthy for today. So go ahead, pick up your calculator. And I would clear the RAM out of there. Second plus sign, 712, so that you don't have the function already in there from last class. All right, so our function is up on the board, g of x. Is it currently in standard form? No, right? Usually we want the biggest exponent first and then to work our way down. Do you think your calculator cares if it's in standard form?
Nope.
It does not. So you have the ability to just put this in just as it looks. But for practice, let's rewrite this in standard form. All right, let's rewrite it with the biggest exponent first. So we'd have negative x to the 4th minus x cubed plus 2x squared plus 2x plus 5. That was just for practice so that we remember, right, those things. I'm going to go ahead and open my calculator and I'm going to turn on my windows. There we go. Go to y equals. Let's go ahead and put all that information in. Negative x to the 4th minus x cubed. Make sure you pay attention to the difference between the minus button and the negative button. Plus 2x squared plus 2x plus 5. Then hit the graph button. You should see something that looks like that. Anybody getting an error or seeing anything different? Just raise your hand and swing on by. Questions? We're good? Okay. Looking at this polynomial function, how many maximums do I have? 2. 1, 2. Anytime it goes from increasing to decrease, we're going to call that a local maximum. How many minimums? 1. How many zeros? 2. So we have 5 points, 5 inflection points, 5 important points that we need the calculator to tell us exactly what those values are, or as precise as the calculator can tell us. So in order to do that, we go to our calculate menu. So second trace. Just using trace will not give us precise enough answers. We need the calculator to actually calculate all of these points. Let's start with our one minimum that we have. So I go down under my calculate menu and I hit enter for minimum. And here's where we get that whole left bound, right bound thing. My recommendation, put your cursor right on the point you're trying to get. When it says left bound, then use the arrows to do a couple clicks to the left and hit enter. You'll notice an arrow up there, right? You're basically telling the calculator somewhere between these two x values, there is a minimum value. Now it's asking for right bound. So I go back to about where my minimum is, and I do a couple clicks to the right, hit enter again. Last but not least, your calculator wants you to do all the work. It asks you for a guess. You come down, hit enter a third time. Once you're kind of hovering over that minimum, and then it will finally give you what the minimum point is. Let's just round to 1 decimal, because we're going to be plotting these. So they're going to have to be kind of, we're going to be guesstimating as we go along. So our minimum is negative 0.4, 4.6. Do you have a question, Melissa? Let's take a look at what you plugged in. Let's double check. Of course. All right, so let's come back to our little table here. We'll fill out our minimum here. We've got negative 0.4, 4.6. If you want to start plotting these, let's go ahead. Negative 0.4, 1.6. Again, you're going to have to be estimating the location of these. Then we come back to our calculator and say, okay, calculator, let's do the maximums, but I have to do them one at a time. This is what's kind of tedious about this process. I go to second trace again. This time choose number 4 for maximum. I'm going to do the one on the left first. So I move my cursor over to about where the maximum is, and then I go a couple more clicks to the left. Put my cursor again back on that maximum, couple more clicks to the right. Last but not least, guess about where it is. And my first maximum is at negative 1.2, 5.1. Anybody seeing anything different? Okay. All right, negative 1.2. A little bit. Let's get our second maximum. Second trace. Number 4. Got to move my cursor over. Left bound. Right bound. Yes. And my second maximum I have at 0.9, 7.0. All right, so we've got a good looking shape so far. Now let's find those zeros. We have 2 separate zeros to do. It's the exact same menu, right? Are we recognizing kind of a pattern to this? Choose number 2 for 0. So usually this is where students have kind of the most problem because the 0 is going to be right at your x-axis. But your calculator is not going to be precise enough. And with polynomial functions, they have big exponents, right? This one has a 4th. So it decreases really fast, or it increases really fast, these. So my left bound, I have to go to the left. Enter. Right bound. And then my guess, notice that even when I'm guessing, I am not directly where I need to be. What I'm looking for, though, when I hit enter, is something that says y equals 0. Now, the tricky part with these calculators is they're trying their hardest to be precise. Did anybody get anything other than 0? You may sometimes see something like this. Like -1e to the -11 instead of 0. This is scientific notation. When you have a negative exponent with scientific notation, that adds a bunch of zeros right after the decimal. So this would be -0.000000001. So it really still is 0. If you see that on your calculator, it still just means 0. Okay, just as a reminder, because you might come along and see that. So we got our first 0, -2.1. Let's find our second one. Second trace, 0. I make sure I'm to the left of my 0, to the right, as close to on top as I can get, and my second 0 is 1.7 and a 0. Go ahead, put those on my graph. There we go. Right, once you have these 5 points, you really just need to ask yourself, by connecting the dot with these 5 points, will I be able to correctly, accurately draw this picture? In my opinion, I think so, right? I think we've got all the important stuff that we need. We can go right ahead, connect the dots, and draw our polynomial. Now what I did on our notes, and then also on our homework assignment, if you want it, is this table. So let's make sure we know how to get to a table of values. On our calculator, I could go to second graph and see some extra points, right? If I felt like I wouldn't be able to accurately draw this picture, I could grab a couple of extra points from this list and be good to go. Do you guys feel like we need to do another example, or are you feeling okay? Because that is it. That is it for today. And I wanted to make sure you had enough time with the calculators here in class to get this homework done before you leave the room. So your homework has 4 problems on it. Just pick 2 to do. Okay? I don't think we need to do as much. Unless you really want the extra practice, just pick 2 of the 4 questions on 6.5 to do as homework.
Thank you.
Of course.
4 of them? Wait, what?